This ship is carrying roughly $200 million worth of cargo. It weighs 200,000 tons. It took weeks to load. And whether it gets through this canal, right here today, depends entirely on whether it rained enough in a Panamanian jungle last month. No rain, no water. No water, no canal. And no canal means the global supply chain has a serious problem. This is the Panama Canal. It carries over 5% of all global trade every year. It generates nearly $5 billion in revenue, and it runs entirely on rainwater. No backup, no alternative, just clouds. Here's what almost nobody outside the shipping industry knows. The canal is not some passive ditch through which ships drift. It's a machine, a water machine. And right now, that machine is under threat. To understand why water is the canal's Achilles heel, you need to understand what the canal actually does and how insane the engineering is. Before the canal existed, a ship sailing from New York to San Francisco had only one option: sail all the way around the southern tip of South America. That's an extra 15,000 kilometers, an extra 3 to 4 weeks at sea. Extra fuel, extra crew wages, extra risk through some of the most dangerous waters on Earth. The idea of cutting through Panama had existed since the 1500s. Spain's King Charles I discussed it in 1534. France tried and failed catastrophically in the 1880s. Around 20,000 workers died. The company went bankrupt. It was a disaster. Then, the United States stepped in. U.S. construction began 1904. Canal opened August 1914. Dynamite used? Approximately 61 million pounds. That's roughly equivalent to the combined explosive energy of the Hiroshima and Nagasaki atomic bombs. Workers employed, 56,000 plus. Official death toll, U.S. construction phase, 5,609. When the canal finally opened in 1914, it didn't just shorten a route, it restructured global trade. A journey from New York to San Francisco that once took 27 days around South America now took under 11 days. The world got smaller. Now, here's what most people picture when they imagine the canal: a flat ditch. Water on both sides, ships floating through. That is not what the Panama Canal is. The Isthmus of Panama has a land ridge running through its middle that sits 26 meters above sea level. There's no flat route. A ship can't just float through. It has to be lifted up and over. The solution is a lock system. Think of it as a staircase made of water. A ship enters a lock chamber. Water flows in. Not pumped, just gravity from the lake above. The ship rises, the gate opens, the ship moves to the next chamber. This is repeated 3 times going up to the level of the lake. The ship crosses the lake, and then it's lowered back down in 3 steps on the other side. The whole process takes 8 to 10 hours. And that phrase, water flows in from the lake, is the entire problem. Remember the question I said I'd answer? Why can't they just use seawater? The Pacific Ocean is right there. The Atlantic is right there. Why does it have to be fresh water from a lake? 4 reasons, and together, they make seawater completely unusable. Reason 1, corrosion. The lock mechanisms, the gates, valves, and sluice machinery, are made of steel. Salt water corrodes steel at a rate roughly 30 to 50 times faster than fresh water. The original lock gates have lasted over 100 years. In saltwater, the maintenance cost and replacement cycle would be catastrophically expensive. The locks would essentially be eating themselves from the inside. Reason 2, drinking water contamination. The canal administrator himself put it plainly. Every time we open the gate that leads to the sea, seawater is mixed with fresh water. Lake Gatun doesn't just feed the locks. It supplies drinking water to over half of Panama's population, including Panama City. The water treatment plants along the canal have no desalination capacity. Injecting salt water into the system would contaminate the freshwater supply for millions of people. Reason 3. Geography. For salt water to work, you'd essentially need a sea-level canal, a flat channel all the way through Panama with no locks at all. That's what the Suez Canal is. But as the canal administrator noted, Suez was much flatter and it was sand. Panama is mountainous, jungle terrain. The only reason the lock system works is because of gravity and fresh water from above. Redesigning it as a sea-level saltwater canal would require one of the largest excavation projects in human history and would destroy the entire country's freshwater supply in the process. Reason 4. Biology. Saltwater mixing into the freshwater lake would cause catastrophic ecological damage, killing fish species, destroying the freshwater ecosystem, and creating dead zones in the lake that have supported Panama's biodiversity for over a century. So seawater is not an option. Not now, not ever. Not without rebuilding the entire thing from scratch. The canal is locked into fresh water. And fresh water comes from one place: the sky. Every single time a ship passes through the Panama Canal, the system uses approximately 197,000 cubic meters of fresh water. That's roughly 200 million liters per ship, every ship. Water used per day, approximately 7.2 billion liters. That's roughly comparable to the daily freshwater consumption of an entire small country like Austria. That water flows out to sea. It doesn't come back. The only way to replace it is rain. Panama sits in a tropical rainforest. Historically, it rains almost constantly, up to 2,660 millimeters of rainfall per year. For over 100 years, that was enough. Nobody questioned it. The lake stayed full, the locks kept working, the ships kept moving. Then 2023 happened. El Niño hit. Rainfall collapsed. Lake Gatun, the man-made reservoir that feeds the entire lock system, fell to its lowest levels in recorded history. The Panama Canal Authority was faced with a brutal choice: restrict operations or risk the lake running dry completely. The numbers are stark. Normal daily transits, 36 to 38 ships. December 2023, 22 ships per day, canal's lowest since records began. Normal maximum vessel draft, 50 feet. Draft restricted to 44 feet. Transit decline, 9,944 transits versus 14,080 the previous year. Approximately $200 million drop in earnings. At 44 feet of draft, fully loaded container ships and LNG tankers cannot pass. They either leave cargo at the dock or they sail a different route entirely. Ships started backing up. Wait time stretched from hours to weeks. The auction system the canal uses for priority slots, where shipping companies can pay extra to jump the queue, saw prices explode. Some vessels paid hundreds of thousands of dollars in surcharges just to move faster. Now, let's talk about what this actually costs. Not just Panama, not just shipping companies, but people sitting in apartments in London, Sao Paulo, and Chicago who had no idea a Panamanian lake could affect their lives. Chain reaction number 1. Your car. South Korea is one of the world's biggest car exporters. Hyundai, Kia, and Samsung Electronics all ship heavily through the Panama Canal route to the U.S. East Coast. When transit restrictions hit, car parts and finished vehicles piled up at ports waiting for slots. U.S. auto manufacturers, who already had lean, just-in-time supply chains from the pandemic years, saw their parts pipelines slow down. Assembly lines in Ohio and Tennessee didn't stop, but they stuttered. New car prices, which had only just started recovering after the pandemic supply crisis, saw fresh upward pressure in late 2023 and into 2024. Chain reaction number 2. Your energy bill. This one is the most overlooked. The United States has become a massive exporter of liquefied natural gas, LNG. Huge cryogenic tankers full of American natural gas normally travel from the Gulf Coast of the US through the Panama Canal and to buyers in Asia. When the canal restricted traffic, LNG tankers couldn't get through. The canal reported that before the drought, there were an average of 26 LNG carrier transits per month. By the time restrictions were in full force, that had essentially collapsed. Those tankers rerouted around South America, adding weeks to already tight delivery schedules. European buyers who depended on American LNG amid the ongoing Ukraine-related energy crisis found their supply chains stretched thinner. Energy costs in Europe, already elevated, got a further push from canal restrictions thousands of kilometers away. Chain reaction number 3. The grain system. The U.S. exports enormous quantities of grain, corn, soybeans, wheat, through the Gulf Coast to Asia and Latin America, much of it via the Panama Canal. When the canal restricts draft depth, grain carriers can't load to full capacity. They either make multiple smaller trips, which costs more, or wait for slots in an already congested system. Some of that cost flows down the supply chain to food processors and eventually to consumers. A drought in Panama made European energy more expensive, delayed your car parts, and added margin pressure to global food prices. Most people never connected those 3 dots. That's how choke points work. So what is Panama doing about it? The good news. The canal has recovered. As of mid-2025, Gatun Lake water levels are back to normal, hovering at around 86 feet, well above the operational minimum. The canal administrator declared it operating at full water capacity. Transits have returned toward 36 per day. The immediate crisis is over. The structural fix, the Rio Indio Dam. But the Canal Authority knows that the 2023 drought was not a one-off. The long-term fix is already in design. A new dam on the Rio Indio, west of Gatun Lake, connected by an 8-kilometer tunnel drilled through a mountain. There are already problems. Over 2,000 people live in the valley that would be submerged. Farmers, families, villages with churches and schools, 90% of them, according to a University of Panama poll, oppose the project. Environmental groups have raised concerns about ecological damage. Legal challenges are building. The project still doesn't have full approval. Construction hasn't started. The canal's own chief admitted the next occurrence of El Niño, expected in 2027, will be a challenge for the canal again, since the Rio Indio project is not expected to be ready before 2030. Let's be precise about the timing. El Niño cycles typically return every 2 to 7 years. The last major one hit in 2023. A moderate to strong return event is being watched by meteorologists for 2027. The Rio Indio project, under the most optimistic timeline, won't be operational until 2030 at the earliest. That means at least one more full El Niño drought cycle will hit before the backup system is ready, possibly 2. The canal was last expanded in 2016, adding a new lane of bigger locks that increased traffic capacity dramatically. What it didn't do was build a bigger water supply. More ships, same lake. Bigger ships, same lake. And now climate change is making that lake less reliable. Here's the number I want you to hold in your head as we end this. The Panama Canal handles somewhere between 5 and 6% of all global trade by volume. That's roughly $270 billion worth of goods per year, moving through 80 kilometers of jungle, 13,000 ships, 160 countries, 1 lake. We built a global economy that moves $14 trillion worth of goods by sea every year. And a significant portion of that rests on a man-made lake in a jungle staying reliably full. There's no plan B, not yet. Just a dam project that hasn't started construction, in a country where the people who'd be displaced are organizing to fight it. The canal has worked perfectly for over 110 years. It's one of the greatest engineering achievements in human history. The workers who built it, many of whom never got their names recorded, gave their lives for it. But it was designed for a climate that was stable, for rainfall that arrived every year on schedule for over a century. Climate change doesn't operate on a century schedule. So I want to leave you with two questions. First, does the world have too many critical supply chain choke points? The Panama Canal, the Suez Canal, the Strait of Hormuz, the Strait of Malacca, and not enough redundancy for when even one of them breaks? And second, when the Rio Indio Dam does eventually get built, and those 2,200 families are relocated, who pays the real price for keeping the global economy moving? Think about it, and let me know below.